Okay, in ellipses part 3, we will talk about the foci. All right, so I have a general ellipse drawn. This one has the major axis horizontal. So when you measure from the center to this vertex here, that's A units in a horizontal way. When you measure to the co-vertex, which is 0b, then that's B units. Okay, so that leads to a couple useful formulas. One is that the length of the major axis is going to be equal to 2 times A. So if this much is A, obviously if you double it, you get 2A. And then the minor axis length is going to be 2 times whatever B is. This is true even if you have the major axis vertical instead of horizontal, because they have it set up where A is always greater than B. So 2A gives you the major axis length and 2B gives you the minor. Okay, now let's bring in the foci. And again, I have this drawn with the major axis being horizontal, but it doesn't really matter. It would be very similar the other way around. Okay, so here's a vertex at A0. Here's a focus at C, 0. So we know that this distance here is B, and we know this distance here is C. And I'm not going to prove it to you, but I'm just going to tell you, if you draw in the hypotenuse of this right triangle, this distance here works out to be A. This is always going to be true then, the Pythagorean theorem. So the legs are B and C, so you're going to have B squared plus C squared being equal to the square of the hypotenuse, which is A squared. So this is not the normal way we do the letters. Usually we like to say A squared plus B squared equals C squared, and A and B are the legs and C is the hypotenuse. But for an ellipse, this is going to be a different arrangement. And the way that we will write it then is C squared is equal to A squared minus B squared. This is what is true for an ellipse. Okay, all right. Now, something you can do with C, besides it just being where the foci is something called the eccentricity. This is usually represented with the letter E. And the definition is E is equal to C divided by A. So it's the ratio of the focal length divided by A. Okay, so what does this tell you at a glance? For an ellipse, the eccentricity will always be between 0 and 1. The closer E is to 0, the more it's like a circle. It gets rounder with smaller E values. The more that it is near 1, that makes it very eccentric or very elongated. Okay. All right, let's try one problem here. It says, find the standard form of an ellipse with vertices at 0, -6, and 0, +6, and the foci at 0, -5, and 0, 5. Okay, now you don't really have to graph it to do this problem, but I find it helpful to picture the situation. Okay, 0, -6 would be down here, 0, 6 would be here. Okay, so those are vertices, and then you have a focus at 0, -5, and 0, 5. Okay, so that's how it's going to be. All right, so the 0, 6, that tells you that your A value is 6. The focus at 0, 5, that tells you that your C value is 5. Okay, so you need to figure out B. So if A is 6 and C is 5, then B equals what? That's the basic question. The formula is C squared is equal to A squared minus B squared. So 5 squared is equal to 6 squared minus B squared. So 25 is equal to 36 minus b squared. So b squared is equal to 36, subtract 25, so that would be 11. Okay, so b itself is actually the square root of 11. All right. And if you were graphing, which technically we don't have to graph in this problem, but if you were, this would be approximately 3.3. Okay, and then you could go out 1, 2, 3.3 for your co-vertices, and then you could have your graph. Okay. Now, the actual question is find the standard form. Okay, so the standard form is going to be x squared over b squared plus y squared over a squared. I know that the a is with the y because the vertices are vertical. 0, -6 is below 0, +6. Okay, now to put in here, I really only need b squared. So this was kind of extra work down here that I didn't need for just finding the equation, because b squared is what goes there. So it's going to be x squared over 11 squared plus y squared over 36, because that's your a squared, equals 1. That would be the standard form.